Today we're going to be taking notes on slope-intercept form. Now we touched on slope-intercept form already in the last unit, and today we're going to go ahead and expand what we know about that as well. So we have the equation y equals -1/2 x plus 3. And the question is, go ahead and graph that. So get used to this. You'll be doing this a lot. Here's my y-axis. Here's my x-axis. And I'm just going to go ahead and say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So when I'm looking at this equation, I know automatically this is my y-intercept. My y-intercept is where the line crosses the y-axis. Okay, so our y-intercept is where our line is going to cross my y-axis. So I automatically know that one of my points, because it's 3, it's positive 3, one of my points is right here at 0, 3. So now I know that I have a slope of -1, 2. So that means it's rise over run, remember that. So I'm going to go down 1 over 2. Down 1 over 2. So my line is going right here. And I've identified 2 points to be 2, 2. To be one of the points of this equation, and another point to be 4, 1 is another point on this equation. So that -1/2, that's my slope. And remember, slope is always rise over run. So let's go ahead and talk about a real-world example dealing with an equation. So we have a ramp slopes from a warehouse door down to the street. The function equals -1/3 x, that should be an x in there, a -1/3 x plus 2. Models the ramp where x is the horizontal distance in feet from the bottom of the door, and y is the height in feet above the street. So it says graph the equation. So again, we're going to go ahead. Let's create our x and y axis. Trust me, you're going to be making a lot of these in your math life. Even in calculus, I had to make these to model what it would look like. And all you really have to do, unless there's extreme, is go out 5 north, south, east, and west. Okay, or positively, negatively. So I have I have my equation y equals -1/3 x, that's what I forgot in the original problem, plus 2. So that basically means that 2 says that it's 2 feet from the ground. If you think about this in terms of sea level, that 0, or our origin, is ground level. And then we're talking 2 feet above the ground. And so it slopes out -1/3. That's my slope. So my slope is -1/3, and my 2 is my y-intercept. So if I go down, -1/3 is my slope, I go down 1 over 1, 2, 3. Down 1 over 1, 2, 3. So here I have a point 3, 1, and this point was 0, 2. And my line would continue. And so the question that I added on to this was, how far from the door will the ramp actually hit the ground? So we want to think about this line here, this part right here, as our ramp. So again, we're going to go down 1 over 1, 2, 3. So the point where it hits the ground would be at 1, 2, 3, 4, 5, 6 feet. Because our coordinate point is 6, 0. That's our coordinate point. But what our answer would be 6 feet. Okay, so let's move on. What we want to do is create equations from slope and y-intercept. Basically, given the slope of negative 2/3, given the y-intercept of 4, all we're going to do is take our slope-intercept form, which is y equals mx plus b, and we're going to go ahead and make it y equals negative 2/3 x plus 4. Here I have a slope of 5, a y-intercept of negative 3. So I'm using y equals mx plus b. And so that's going to be 5x, y equals 5x. Because it's a negative 3 that I'm dealing with, I'm not going to say plus negative 3. I'm just going to say minus 3. So now based on the model, which of course you don't see here, let's go ahead and draw our model. Okay. So our model, sorry about that. So our model is going to be, again, we're going to go ahead, draw our y-axis, draw our x-axis. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And it's not perfect. And it's okay if yours isn't perfect either. And I have a point of negative 2, negative 3. So I'm going to go back 2, down 1, 2, 3. And I have another point of over 2, negative 1. And based upon this, I want to go ahead and write an equation that models the linear function known in the graph. So this is all I know. I know that I have these 2 points. I'll connect them with a line. My line isn't absolutely perfect, obviously, as you can see, but I know that negative 2 is my y-intercept. Now, the final thing that we can use to figure this out is using our slope formula. So I want to do the change in y over the change in x. Here's my y values. Okay, so I have negative 1 minus negative 3 all over 2 minus negative 2. And if I go ahead and I do the math, -1 plus +3, that's going to give me a 2. And 2 minus -2, that gives me a 4. So my slope is going to end up equaling slope equals 1/2. So, knowing that my y-intercept is -2, my slope is 1/2, I can go ahead and put in to my formula y equals mx plus b, y equals 1/2 x plus minus 2. Okay, so let's go ahead and talk about the parent function. Finally, we want to talk about the parent function. Now, if I have a coordinate plane, my parent function is the equation y equals x. Okay, basically, if x is 1, y is 1. If x is 2, y is 2. If x is 3, y is 3. And it's just a perfectly diagonal line, so -1, -1. Okay, so that's our parent function. So if I want to talk about slope reflection, basically, if my x is positive, I want to make my y is going to be negative. All right. So if it's, and that reflects it over the x-axis. That reflects it over the x-axis. Okay, so let's think about it. If x is 1, y is -1. If x is 2, y is -2. If x is 3, y is -3. And that's why this red line is our reflection. All right, let's talk about slope dilation. All right, this is a fancy term. Again, if I have y equals x, all right, if I have y equals x, I can dilate my slope. Again, here's my parent function. Okay, y equals x. If I make my line go like this, okay, then basically what I've done is I've created a slope that's like y equals 1/2 x. If it becomes steeper, okay, then I have a slope that could be y equals 2x. Okay, so basically all you're doing is you're multiplying x by either a half or not just a half. Let me take that away. By a fraction to make it less steep. And then you multiply x by a whole number to make it more steep. All right, finally, translation. If I have my parent function, again, and again, the parent function is y equals x. My y-intercept is 0, okay, because basically I could say x plus 0, and that's my y-intercept. If I said y equals x plus 2, basically what I've done is I've translated this line. The slope has not changed. I've translated this line, and now I've moved it up 2 spaces because that's now my y-intercept. If I said y equals x minus 3, Now my y-intercept has moved down 1, 2, 3, and now my line is here. Okay, so that's some things that we want to go ahead and think about when we're talking about our parent function, and some things dealing with reflection, dilation, and translation. Thank you.